Hi everyone, my name is Kingsley Idoko, and I'd like to welcome you to this video on Twice NAT, right? Written as Twice NAT. I should probably have written it before the start of the video. But anyways, so we want to talk about Twice NAT. We want to look at what Twice NAT really is and what it can help us, what kind of problems that can exist within a VPN kind of setup, and how Twice NAT can really help us to solve issues that relates to maybe overlapping IPs or just making your VPN connectivity a little bit simpler, right? So we want to look at Twice NAT, kind of an advanced implementation for Twice NAT. So we're going to look at two specific implementations. One is when you are coming from the inside to outside, right? So pretty straightforward. And the other one is when you are coming from outside to outside, right? For outside to outside, that could apply to remote access VPN users who wants to access certain services that is not local to us but is from a third party. So they come in through outside interface, remote access VPN, and then they need to also route back through that VPN, through a different VPN to the customer different location. Okay, so that is really what Twice NAT is. So we want to look at like kind of an implementation, maybe advanced or intermediate. I don't know how to describe it. But if you look at this topology, so this is what we want to talk about, right? So this is a third-party provider in AWS, right? So we assume this is who they are, and they have a specific web services that we need in our company, right? And we want to access these services through VPN, not internet routing, but through VPN. So the service is only exposed through the VPN. So what we are required to do is set up a site-to-site VPN from our London DC, right? So we have a site-to-site VPN from our London DC to their firewall, right? And then they expect us that anytime, wherever the user is, whether it's a remote access VPN user, whether this is actually a desktop computer or a server or in London or Frankfurt, anywhere, they expect us to come through this site-to-site VPN that we have with them to access this service. Okay, so yeah, so that's really the whole idea of this. Now there's some little caveats, or there's some little limitations to what we can do. Now they don't want to see all our subnets. So if you look at the entire infrastructure, you see we are using different subnets depending on the location of the user or the application, right? Now here we are using this subnet here we are using this subnet, here we are using this subnet, right? And for the remote access users, they are coming with different subnet entirely. Now, for these users, if you understand how site-to-site VPN really work, for all these users to be able to talk to this application, somehow this ASA we have here needs to have a route to all of them, right? It needs to know how to reach them. So for normal site-to-site VPN, you always have the local subnet, right? And then you have your remote subnet, right? So in this kind of scenario, if this users needs to be able to access this server, then in the remote subnet, the third party will need to include all these various prefixes that we talk about. But they are saying, look, we cannot do that. You need to come in when you're coming to hit this server, to reach this server. You need to come with at least in one range. That's just what we allow. You can't be coming from different ranges, right? You need to come with just one range. Okay, so in that kind of scenario, what you need to do is you need to find a way to do, hide this whole topology, this whole IPs within one single subnet or one single IP, right? Maybe something like it's dynamic IP, where wherever you're coming from, once your destination is these applications, we're going to change your source IP. That's the whole idea. That's what Twice NAT can help you to resolve, right? You could also have a situation whereby this subnet is already being used within our infrastructure. Maybe in London DC, we're already using this subnet there. Maybe in Frankfurt or anywhere, we're already using this subnet, right? So we can literally point to this subnet because it already exists within our infrastructure. So what you need to do is to say, we have to create something like a floating IP, right? Just come up with a different subnet that is not being used. You can say maybe it's 10.100.100.10. You're going to tell all these users, right? If you are trying to access this server, which is the AWS server, please point to this floating IP, right? Which will exist in our London firewall. And then when the traffic, if the destination is this IP, the ASA sees it and say, oh, I'm going to translate that IP to the actual destination, which in this case becomes 10.70.22244.10, right? So what we end up doing is that as traffic moves from the source to the destination, the source IP is going to change, right? And also the destination IP is going to change, right? That is what Twice NAT helps us to solve, where you are changing both the source and the destination IP. So I kind of came up with this topology where it's not a new topology, and we're going to see how we can use it to solve that kind of situations where you have subnets everywhere with overlapping subnets, and you need to talk to a third party that might be using your subnet, or you don't just want to use their subnet because in the future you might end up using their subnet, so the IP is all over the place, and so we need to find a very efficient and effective solutions to solving this problem. So here is what we need to do in this topology now, right? So what we have is this. We have our remote access users, both in London and in Frankfurt, right? They all come in. So London hits this device, Frankfurt hits this device. They come in through remote access. They get assigned an IP from this pool, right? And so, yeah, that's the basic stuff, what we've always done. Now, between this ASA, there's a site-to-site VPN, right? That will exist. And then between here, you also have a different site-to-site VPN that will exist. And so what we want for Frank users is that they are going to come in, right? So he comes in through remote access VPN, and then the traffic goes all the way, right? So it depends on the destination. If he needs to talk to this server, we push it to the server, like this way, right? But when he needs to talk to the web services in AWS, then the traffic should what? Help in, right? Which we've already talked about, straight to this user, okay? But just like we have said, we don't want these users to know about this IP. We're going to create a floating IP that everybody is going to point to get to this server. All right. So our first task now is to build the topology. It's already built halfway, really, but we can just throw in some things like the remote access VPN is already configured. Site-to-site is partly baked, not fully up and running, but so we're just going to set everything up, do some kind of revisions around how remote access and site-to-site are built, set up, and then we kind of look at the actual meat of this discussion, which is how we can actually implement Twice NAT. Okay, Twice NAT. All right, so I'm going to pull up the topology now. So I'm using if, which is what we've always used in the past. This is the if topology, so I'm gonna clear this up, right? So yeah, it's just similar to what you see in the topology there. You have so this is a Frankfurt, this is a London. These guys are actually active standby. I did not this. We don't really need the secondary here. And then this is the like the AWS site, and these are the applications. Yeah, for remote access users, of course, it's just some kind of somebody here that connects, that has internet access, so they're able to talk to those public IPs. So for the remote access users, I'm going to be using I have a VM here, right? So I have a virtual machine that is running VMware Workstation, and we're going to try how we can connect. So there's already an NA Connect client installed. We don't really need to go through all of that process that we've already done in the past. We just want to really focus on what we want to discuss in this video. Okay, so this is the topology again, and I'm going to bring out the console access to the ASA. So I have my London primary, I have my Frankfurt, then I have the other location. Now, where do we start from? So we need to just confirm. So the first thing we do is let's confirm that side to side between this location is fine, right? It's not fine, it's not even configured, but it's configured halfway. So we just complete the implementation, and we test that this two subnets can talk to each other, right? And then yeah, so let's do that first. Then we'll take it from there. So the first thing I'll do here now is to just widen the topology. Maybe not too much, just a little bit wider. So on the London firewall, if I say show run objects, so I've already created all the objects, right, that relate to all the subnet that we'll be dealing with. For example, if you check here, you see we already have the the /24 subnet, which is for the London DC server, right? And you have 172 subnets. So so there are a lot of subnet that's already defined here, but you probably understand it more in show run object group. So I've decided to use object group here as well. So for the London AWS local, so what this object group is doing is this. Let me see if I can drag it forward a bit. So here we have the London AWS local. So for the side to side between these two devices, these two sites, I mean, right? We have what we call the London AWS local. So London to AWS, the local subnet. So the local subnet here is the /28, which is this. I've already created the object group. Now we also have the Frankfurt remote. Now this applies to, drag it down again. So this applies to the site to site you have between here, right? Now when I say London Frank remote, it means London to Frankfurt remote. So the remote subnet between London and Frankfurt is this. That's what you have also created here. Then we have the London Frank local. So these are the subnets that we have here, which is this. So it's already created too, London to Frankfurt local. We have this IP. We're going to talk about this IP later. That's going to be the floating range that we talked about. Then we have the AWS remote. Of course, this is the remote. Where's AWS? That's not AWS. Just trying to explain what each of the subnet is doing. So we also have the where are we now? So this is the Acme. We said, so this is the London Frankfurt local, which we've already explained. We have the AWS Acme remote, which is this subnet, right? And then we have the SSL VPN users, right? Which I already explained that the SSL VPN users are these users here. So all the object groups are created. So what we just need to do now is, just reference them and use them as we want to suit our design or our solution. Okay, so I'm going to delete this, and I'm going to try to drag this topology to one side so that we have more room to configure. Then just leave it here. So here we just want to focus on London Frankfurt. So let's get the side to side running. So the first thing, so we only have the object group created, but of course the tunnel group and the group policies, everything is already set up. So I'm just going to come here and say show run crypto map. So you see the crypto map is already set up, right? So Frankfurt is 1.10, right? 1.10, that's the sorry, that's actually, so it's actually 1.20, right? So we are using IPv2, we are not using IPv1, and then yeah, so there's really nothing here, right? So what we just need to do is to match the access list, which is really not, there's really no access list here. So we're just going to say show run access list. There's no access list, so we just need to create the access list. So I'm going to come here now and say access list, right? It's going to be between London to Frankfurt, right? DC, site to site, if you want to put more description, right? I'm going to say I just want to permit what now. So before we do this, let's pull up the object group again. Show run objects-group. right? So it makes it easy. So we're just going to say access list, right? So we say London to Frankfurt, DC, site to site, right? Site to site, yeah. Okay, so I'm just going to say if the traffic is coming from, so if this traffic is coming from where now, it's going to be from London, Frankfurt local. So this is the object group. So it makes more sense to create object group, makes it a lot easier. So if it's coming from this local subnet and it's going to London Frankfurt remote, right? So we can come here and say object group. Yeah, so objects, let's say question mark. Why is what's wrong? So it looks like it looks like we don't need the object group, I think. Yeah, so just take this out. Let's see. Permit IP, sorry, permit IP, which we said is this. Let's do the question mark now. Okay, so we need the object group. Object group, so which in this case is Frankfurt local, and then the object group again for, we said it's for the remote, right? Which is London Frankfurt remote. Okay, then put it there. So the access list is created. So if I say show run access list, yeah. So we're saying if it's coming from London, which is this object group, and it's going to Frankfurt, that's the access list. So what we just need to do is reference it in the site-to-site VPN, right? Show run crypto map. So I'm just going to come here and say for this, which is .11, I'm going to say match address, right? So we are tying it to this access list. So this is what defines the interesting traffic. Okay, so show run crypto map, crypto, not properly set, run crypto map. Yeah, so that is done on this end. Let's also do from the Frankfurt end as well. So it should be, so I'm just going to say show run object group as well, and then let's say IP access list. So we're going to say fra to London, DC, site to site, permit IP. This comes from frac local, which is this. And it's going to, so you need to put the object group as well. Object group, which is this, and then object group, objects. There's something wrong here as well. Permit IP object group. Let's say permit IP. Why did I spell something wrongly? Oh, sorry, my bad. So let's copy this. Let's say we don't need the IP at the beginning. Object group, so it's going to be, if it's coming from this local subnet, onto object group again, which is the remote subnet. So this is the remote subnet we said, right? Yeah, so that's the remotes. Okay, show run access list. Yeah, so the two interesting traffic is define what else is left. Of course, the NAT rule, right? We need to say if it's coming from this server, let me get my pen. So we need to say if it's coming from this subnet and the destination is this subnet, don't NAT, right? We do NAT exempt for that. So let's start it from here. It's almost still going to be the same thing. So we just say, so if I say show run NAT, there's no NAT rule at the moment. So we're just going to say NAT, if it's coming from the inside and it's going outside, right? And it's going to be static route, source NAT, source static. And then we say if it's coming from this local subnet, don't NAT it. So NAT it to itself, which is NAT identity, right? So we're going to say destination is also going to be static, and then also dot NAT, sorry. So show run NAT, yeah, show NAT gives you a breakdown. You say show NAT details, it gives you a better detail of what you have. So we are saying if it's coming from this, translate it to itself. If it's coming from this or this, if the remote is this or this, don't do anything, just let it go. Okay. Yeah, so we need to also do the same thing on the London side. So we're going to say show run NAT, show run NAT, show run NAT. There's no NAT rule, yeah. So we're going to say show run object groups, because we need to reference the object group. So we say NAT from inside to outside. Okay, as it's coming from inside to outside, we say the source is going to be static, and yeah, so we're going to say if it's coming from London local, okay, and we don't want to NAT, and then we say destination. We've done this in the past, so we don't want to waste much time trying to explain. And we say this, and then of course you need to say no. Let's say I hope there's no error. So you need to say no proxy app, and then route lookup. Yeah. So don't allow proxy. So here to show run NAT, we can also add that here. Let's say no proxy route lookup. Yeah. Show run NAT. So everything is good. So with that, now I never showed you before that we actually have the tunnel group already set up. So I show run tunnel group. So we already have everything baked, right? So this is the tunnel group. There are pre-shared password, you know, I've already gone ahead to do that. So we also have that here. Show run tunnel group. So we already have that for the 130, right? So if everything is good, we should be able to ping between both servers. So in this case, I'm using, so let's see, this is London server. Yeah, so this is my London server here. So just put it here. This is like a Windows server application system, I mean. So delete this, and then let me also pull up the other one is Frankfurt, which is this. Okay, so we should be able to ping each other now. So by saying ping to, this is London, I'm going to say ping to 172.16.10.252. yeah, so let's see if it doesn't work, we check why. Ping to 10.0.0.20. So let's just do a continuous ping here. Same thing here. Let's do a continuous ping here as well. Okay. Okay, so currently the pings are not going through. So let's figure out why. So I'm just going to come here on this device. So the first thing is, let's check the access list. Is it being matched? Let's bring it wider. Yeah, so there's a hit count for the access list. Let's also check the frag, show access list. Yeah, okay, so there's no hit count here, right? So we'd say if it's coming from 172.16.10.0 and the destination is 10.0.0, so it should actually hit this access list, but for some reason it's not being matched. So let's check the crypto map. I don't think we added it here. Show run crypto map. Yeah, so that's the reason. So we just come here to 10, There's a match address, which is this access list. So this is going to trigger the VPN connection. Let's see. So now I believe the tunnel is up. And if you do show VPN section, DB, LAN to LAN, filter by IP address, we don't really need to filter because it's just one. So as you can see, yeah, so we have a packet going back and forth. So side to side between these two locations is fixed, and these two servers can talk to each other. Let's also fix the side to side between the AW. We know we don't own this site really, but for this lab we own it. So we'll fix this side to side VPN up, get this running, and then so for now we're just going to add this subnet and this subnet. So the local subnet will be this, the remote subnet will be this from this ASA perspective. So let me grab my, let's go back to the CLI, in this case take it up a bit, and yeah, so on the London end, back to the London end, so if I say show run access list, so we're just going to repeat the same thing. So first you say show run object group, and so we can just create the access list now. So access list, so we said if it's coming from London to AWS DC, site to site, and then we're going to say permit IP. So the local subnet here is going to be London admin local, London AWS local. Yeah, so this is it. We need the object group. So it's going to be this, and the other object group. Let's see. So where are we getting it wrong again? So there should be a space. So object group. So the remote subnet is going to be AWS Acme AWS remote. So we just reference that. Okay. So show run access list. Yep. So this is what defines the trusted traffic, right? So we also need to do, let's just repeat. Let's say show run object dash group object. I'm really having a bad typing. Show run object group and show run NAT. So let's just, so we just need to replicate this. So we're going to say if it's coming from inside to outside, config T, and then we say if it's coming from this local, right? Loading AWS local, we are not changing anything, right? And then we also say destination, in this case is going to be static, and then we say it's going to be AWS Acme remote. Okay, and then we can say no proxy, then route lookup. Sure or not, so everything looks okay. So let's also check the crypto map. Sure on crypto. Yeah, so sure on crypto maps is properly filtered. So we need to match the address as well for the 1.10. So sure on access list, which is the access list we just created. So for this, we need to reference the access list. So match address is going to be this access list. So loading AWS. Okay. So show run access list. There show run crypto map. So I believe this should think that solves issue with this subnet. So let's go to Acme, which is this firewall. So if you say show run object group as well, we've already defined the object group, just two basic object group already. So show run access list. right?